Hello, ladies and gentlemen, and I thought it might be a nice idea to give you another example. So let's go for a sketch of this function, f of x equals x over x squared minus 1. And we're going to be looking at the 6 characteristics of this curve, the calculus characteristics. So we're going to start off with domain. And looking at this function is a rational function, which means we're going to have a problem wherever we divide by 0. So x squared minus 1 can never equal 0 for us to get a range value at that point. So we're going to have x squared cannot equal 1, x cannot equal plus or minus 1. Now guys, let's make sure that we know that. It would really be upsetting for me for someone just to tell me that x cannot equal 1. You do understand that what's happening here is we take the square root of both sides and it's plus or minus the square root of 1. So there's 2. And we're going to have 2 vertical asymptotes there. If we want to write it out now, it's going to look like this. So the set of all x such that x cannot equal plus or minus 1. X is an element of the real numbers, which means that everything will be connected. And we have the end of the brace brackets. So number 2. What did we say? I guess we could look at intercepts. So for an x-intercept, we're going to set y equals to 0, or in this case, that's f of x equals to 0. So you'll have x over x squared minus 1 equals 0. A little shortcut for doing this is pretending that it's over top of 1 and cross multiplying. So it's x equals 0, so 0, 0. Now that's the origin. So that's going to be your x-intercept. For a y-intercept, we're going to set x equal to 0. So it'll be f of 0, which will be 0 over 0 squared minus 1, which also is 0. So again, that origin is going to work as both our x-intercept and our y-intercept. 3, might as well look at symmetry. So test for odd or even symmetry. What we do for that test is we plug in negative x in for f of x. So looking up at f of x, we're going to put in a negative for that top one. We're going to put in a negative for the one that's being squared. We're going to take a look at this. That's going to work out to x over x squared minus 1. And a little trick that I like to do is common factor out that x from the top, and it's going to leave us with this, which if we look, we notice that that is the same as f of x. So in fact, what we have here is negative f of x. That is the test and the result for giving us a function that is either even or odd. Now sometimes I forget and I can't remember which one it is. So what I like to do is I do a little sketch, and my favorite little odd or even function I draw like that. So if I come out here to x, I'm going to come up to a positive f of x, and I'm supposed to get a negative f of x. So if I go the same distance out here, negative x, it's supposed to come down to negative f of x. So therefore, we're looking at f of x is an odd function. Now that's kind of mean going around talking about functions and saying, hey, you're an odd function, nah, 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 nah. So maybe we'll like to say, and we'll say that it is symmetric about the origin. Okay? So there we go. We've got those 3. My next test is going to be for asymptotes, and I'll probably stop that and start the next video.